properly, and also the content is visible obviously. So before we start discussing about the yesterday's problem, if you have any answers to the question that I had posed yesterday at the end of the session, you can definitely have discussion on the chat window. But along with that, before we go proceed ahead, I'm going to show you this particular online compiler, which is referred to as onlinegdb.com online C compiler. So by default, if you open this particular, so I'm just refreshing in order that I should show you how it looks like when it is opening. Okay, my internet connectivity today is a bit tad low, so please bear with me. Okay, so this particular sidebar I can hide using this arrow. This is the editor window wherein you can type in your program. Here already something is already typed. You can see the controls over here at the top. I have this run button to execute the program, but before executing I should check on this side, on the right hand side, which programming language I want to program into. So I can see there are lots of programming options available over here, but since right now we are talking about C programming, we'll select C. Okay, and by default when you see C program, onlinegdb.com/online_c_compiler will appear. If I say choose some other programming language like Java, I would see a Java hello world program over here. Okay, but I want C program, so I'll choose C, and then this thing will change. It should change. It will take some time. As I told you, there is some networking issue and it's not asynchronously updating today, so bear with me for the day. I'll just hide this off. This is my C program now. Now this is the run option, then there is a debug option, then there is a stop option, share, save, beautify, and there are other options like download as well. So I can type in my code, I can download the code and go further as well. Okay, so these initial comments I will just remove because I don't want those comments in my program. And now you will find this program pretty similar to the programs that I write in the Linux. That is, I have always int returned from the main, and at the end of the main function I have the statement return 0. Okay, so to get acquainted to that style of programming, I introduce you to the. So I am hitting the run, and this window below you are going to get your output. Okay, hello world, and it will ask you to press enter to exit the console, but before that it has said program finished with exit code 0. Why exit code 0? Because I am writing return 0 over here. Okay, generally in C program there are two exit codes which are important. If the exit code is 0, that means there are no errors in the function that is executed just now, and if the exit code is other than 0 or 1 rather, then the program must have exited with error. This is convention, this is not a compulsory thing. You can have exit code numbers between 0 to 255, any number like that, but 0 indicates definitely a successful execution and 1 indicates unsuccessful execution. Apart from that, different people might use different number to indicate error codes. So sometimes you might get an error code 11 on Linux operating system that is indicative of segmentation fault. You will get to know about these errors somehow later, but now I'll take the same code that we had typed yesterday. I have that in this particular window on my local machine. I'll just paste that code into this editor of GDB. What I'm going to show you now is, now if I want to use this particular GDB for debugging the program, how to do that. So that is what we are going to see, how to debug a program using GDB. I had at the end of the lecture yesterday told these particular thing, but some of you had left, so some of you have not tried doing it. We'll see today how to basically debug your code. Okay, so there will be definitely ads and all, because it's a web application. You can just hide those ads and say this ad is not appropriate, so they won't show it again if you don't like the ad. Okay, now going back, this is my code editor. These are line numbers, and say suppose I want to execute this code up to this is where I take input, right? Line number 9, 10, 11, 12. And after line number 12, I compute the value of the angle in radian. So I will go in this particular margin besides this line number and put my cursor over there. If I put it once, there will be a red dot. If I put it again, that dot will go off. So I will go to a particular line and hit that particular margin. This is going to actually create something called as a breakpoint. What does a breakpoint mean is, whenever you actually have a breakpoint in a program, your program's execution, generally you know that whenever I compile a program, the execution is like the entire program executes as a single unit. All these steps are executed by the compiler, and whenever the program is interpreted, it is interpreted line by line. Okay, so whenever I have a breakpoint inside my my program, the compilation kind of execution will occur till that particular line, and the execution will halt at that particular line wherever you have actually used a breakpoint. Since the execution halts there, we can use debugging mechanism that we have with our integrated development environment to know what are the values of different kinds of variables at that instance or at that snapshot. Okay, you must have already have some idea of debugging in case of Turbo C3 editor, but now since many of you might not have Turbo C at home and this particular online GDB is available online, I am telling you how to use it in order to debug the program or stepwise execute the program. Once the program halts at a particular line, then onwards I can actually execute the program line by line, and how to do that we will be seeing now. So I have added a breakpoint. That's the first step of debugging. I can add the breakpoint at some part of code, but if I add a breakpoint at say declaration, that is line number maybe 6, 7, 8, then those are just the declarations that doesn't produce any output. So breakpoint will stop until it hits a line that generates an output. So even if I have a breakpoint at line number 6, my program execution will stop or break at printf statement, the first printf statement that it encounters after 6, 7 and 8 line. That is on line number 8, the execution would stop. Okay, so now I have selected line number 13 because I want this program to execute normally till it takes input, and after that I want to know how the variables are changing their value. Okay, now I will actually change few things in the program to make the program look like similar to what it was yesterday, because yesterday there was some different things over here. Give me a second for doing it. This was double, so that we will be consistent with whatever we had earlier. So I have done the changes. Remember another thing, when you start debugging, you are not able to edit the program until you stop debugging. So that's another thing that you need to know. So before starting debugging, first and foremost thing, edit your program properly to a state which you want to debug. Then save it. In this particular environment, web environment, you need not save it. But in general, in Turbo C3, you need to first save the program and then proceed for debugging. Create a breakpoint in the execution. The breakpoint also helps in if your program is very big. This program is not that much bigger program, so there is no issue as such if I actually execute it stepwise manner right from the first statement. But in general, if you have very big program and you want to debug a part of it, it is always better to have that breakpoint just before the part you want to debug. Fine. Now the next thing that I will do is I will click on this debug button. This will create 1 and 2 additional panes. So these are called as panes or windows or subframes of the page. Okay, you will see that I am using GDB, and you will see this syntax /user share gdb init no such file or directory. So this is very much similar to some sort of file representation that you saw on my Ubuntu machine, right? So this is actually internally running it on some Linux server and showing you the output on the web browser. This is what it is doing, and it is showing you in a visual manner. That's the only difference. Okay, now going ahead, you will see over here local variables. Okay, you will see over here the some sort of a expression evaluation. So I don't want an expression to be evaluated. I'll remove that, and this is the breakpoint or watch points. So you have added one watch point, and that is on at line number 13 in main program, and here exactly is the line number 13, right? So I have started the debugging. Now the debugging menu is available in this particular pane. ये जो नीचे का pane है input or debug console. So now there are actually two panes this thing is divided into. One is input pane and the debug console. Earlier it was only the input pane and the editor pane. Okay, so there are actually 1, 2, 3, sorry, and 4 panes available to you. This is where you will get to see information about your variables. This is where you are going to control the debugging process, the debug console. So the debug console is where you are going to control the debugging process. Now how you actually start debugging is you just click on start. So I started with first clicking on debug here, then in the pane called as debug console, the header is here, debug console, I'll be hitting start. Okay, fine. So as I click on start, so starting the program, home a.out. So a.out is the executable file. You know from yesterday that if I don't use any name to the output, by default the output GCC stores is in a.out, right? So it is now asking me to enter the angle in degrees. We'll use the same example we given input yesterday, that is 30. I'll hit enter the number of terms in the series. I'll hit 5 and then I proceed. Now as I hit enter after giving this second input, my program has halted. So breakpoint 1 in main at main.c line number 13, which is x is equal to pi slash 180 into angle. So my program has halted here. Has it executed this step? No, it hasn't executed this step. Okay, why I am assured that this step has not executed? You can see over here these local variables have popped up. My angle is 30. I had given an input 30, sure. Value of I is 0. Did I initialize I so far? No, but value of I is by default somehow has come 0. Then sine is equal to 1, which again have I initialized it? Yes, I have initialized sine as 1, t as 1, y as 0. I can see those values here. X, I haven't initialized x with any value. So I have some 6.9 e minus 310, a very small fractional value which is a random value because I am not using a particular storage class. I am just saying it's a double value with x. So whichever memory address x is now referring to, that memory address will have some residual value which is shown over here as garbage value. Okay, you must have learned about storage classes. There are different kinds of storage classes in C, and some of the storage classes have their own way of initializing the variables. Okay, over here I am not using any name of a storage class, so I am using auto storage class. And if you remember, auto storage class generally, whenever you declare a variable with auto as a keyword before its name, or you do not use any other keyword of storage class like register, extern, what else? There are 4 actually. I am not remembering the 4th one. Extern, auto, register, and there is one more. Maybe you remember it. But then static, I guess. Static or const. Yeah, static, I guess. Static. So whatever they are, important thing to remember is these storage classes have different way of initializing the default initializing the variable when user does not explicitly or user does not himself initialize it. तो sum को, फैक्ट को, साइन को, टी को, वाई को मैंने इनिशियलाइज किया, इसलिए वही वैल्यूज यहाँ पे आए हुए हैं. बट देन द अदर वेरिएबल्स आई एम नॉट इनिशियलाइजिंग. सो टी का वैल्यू इनिशियलाइज होने के बाद मैंने चेंज किया यहाँ पे. ओके, आई हैव टेकन एन इनपुट, दैट इज व्हाई इट हैज बिकम 5. I can verify going backwards what is the value of t before this particular line executes. And this is what is the beauty of debugging. We can try debugging the program to understand or confer the concept that we learn. Okay, so debugging is very important in revising concepts, one, and debugging also lets you understand the code execution in stepwise manner. Okay, now without further giving any other things, I'll start debugging the thing. Now what options do we have? The start option is now not enabled because you already started debugging. There is no way I can pause now. Okay, I can continue execution of the program further. So I had actually started the execution Because of breakpoint, the execution has halted. Now if I hit the continue button, the execution will resume as usual.